Hello guys, welcome to my channel. In this playlist we are going to cover machine learning from scratch. If you missed the first video, we covered what machine learning is, how it works and why it's becoming so important in today's world. If you haven't watched it yet, make sure to check it out. Link in the description. Now in today's video, we'll be talking about types of machine learning. There are two types of machine learning algorithms. One is unsupervised learning and the other one is supervised learning. In unsupervised learning, we give unlabeled data to train the algorithms, whereas in supervised learning, we give labeled data. Now, what is unlabeled data and labeled data? Unlabeled data is data without answers. Without answers. Labeled data is data with answers. Now, consider you have data which has feature 1, feature 2, feature 3, so on, and y is the output variable. This is the answer. Now if you are giving the model f1 to fn to train, it's unsupervised learning. If you are also giving y, it is supervised learning. Now let's talk about unsupervised learning models in detail. In unsupervised learning, the model isn't given any correct answers to learn from. It has to figure out patterns and structure on its own from the data. This is where we use unlabeled data. The algorithm isn't told what the correct output is. It just has to make some sense out of the data. Now, why do we need these unsupervised learning models? Sometimes we don't know what we are looking for in the data. In many cases, we'll have lots of data, but we don't know what right categories are or patterns or relationships in that data yet. This is where unsupervised learning comes handy. Let's see an example. Assume I have these 4 different type of objects of different colors and shapes. Now I'll tell the model I want to categorize this into 2 different sets, but I'll not tell what these 2 different sets to be. Set 1, set 2. Do I want all the big objects in set 1 and small objects in set 2? Or do I want all red objects in set 1 and blue objects in set 2? Or do I want all round objects in set 1 and square objects in set 2. I'm not telling any of this to the model. Now this unsupervised learning model could give me any of these results. It can give me this set or this set. Let's talk about some other examples that fall under unsupervised learning. One of them is clustering. Imagine you have a data set of movies, but you don't know what genre they belong to. Now I'll ask an unsupervised learning algorithm to group these movies into clusters based on different features like description, cast or themes. Now it might create different clusters. One can be action, other can be comedy, romance, etc. This is how we can use clustering to categorize different movies. The other one is customer segmentation. Usually in marketing, the businesses use unsupervised learning to group customers to different segments based on their behavior like frequent buyers versus occasional buyers. Now, how does this help the business? It will help it to target specific customer group more effectively. The other one is anomaly detection. This is mostly used for fraud detection. In financial institutions, they usually use unsupervised learning to detect unusual behavior or the transactions. For example, if a customer spending pattern suddenly changes, the system may flag it as a potential fraudulent. This is also called as outlier detection. Now talking about supervised learning in depth. In this, we provide the algorithm with labeled data, which means we give the model both the inputs, that is the features, and outputs, the labels. Now the model learns by comparing its predictions to the correct answers, and over time it gets better at making the predictions. Example, consider you have to train a model for predicting the car price. Now what will be the features? We'll be giving the car attributes from the historical sales, that is we are giving the historical data to the model to train. Now the model will be able to predict the optimal price for the new cars which haven't been sold before. That is, this data is not there in the historical data. This is the new data to the model. Now consider car attributes like color of the car, color, brand, model, and some safety features, etc. All this will be the features F1, F2, F3, so on. Now the price will be the Y, that is label. This will be the price. Now when you give this car attributes along with the car price to the model, it will train it. Now when you give new set of car attributes for a new car, it will give you the price at which it can be sold. That is how supervised learning works. There are again two different types of supervised learning. One is classification and the other one is regression. In classification, the goal is to predict the category of the given input. We can say category or class. Here the output is discrete. You are essentially assigning labels to different classes. Whereas in regression, the goal is to predict the continuous numerical values, which means the output is a real number. It's used when you want to predict something like a quantity or amount. Let's discuss some examples for classification and regression. In classification, we can talk about spam email detection. Here, the model will classify emails into two different categories, spam and not spam. Whereas in image recognition, the model could classify images of animals into categories like dog, cat, bird, etc. And for medical diagnosis, it can be used to categorize the patients into different categories like healthy or diseased based on their medical data. So essentially in this classification, your output labels are categories, things you can count or list like dog versus cat, spam versus not spam, etc. And in regression, we can take examples of house price prediction. You're predicting a continuous value like how much a house will cost based on features like size, locality, etc. And weather forecasting, you can predict the temperature, which is a continuous value. So unlike classification, in regression the output is numerical. Let's consider the house price prediction example and understand how regression works. Let's say you want to predict house prices based on their size. You might have a data set which looks like this. I'll say for 1000 square feet size of the house, the price is 150k USD, and for 2000 square feet it's 250k USD, and for 3000 square feet it's 350k USD, and so on. Now I'll give this data to the model to train. Now I can ask the model what's the predicted price of 6000 square feet size of the house. It would say something around 650k USD. 650k USD or 750k USD based on the relationship it learned between house size and the price. Once the model is trained on this data, it can generalize and predict the price of new houses it has never seen before. So to summarize, we have learned what supervised learning, unsupervised learning, classification and regression are with examples. And concluding it, machine learning is a powerful tool for making predictions, finding hidden patterns and solving complex problems. The more you practice, the better you'll get at recognizing which type of algorithm to use for different problems. In the next video, we'll dive into how exploratory data analysis works, which is a crucial step before you even start building your models. Stay tuned, and if you found this video helpful, don't forget to like, share and subscribe. See you in the next one. Thank you.